Alright folks, we're going to see special types of what we did last time again today. So we're going to practice more factoring. So the first thing I want you to do is see if you can list out the steps to factoring. You're not necessarily solving, just factoring. So you can remember what to look for and what order. Pause the video while you try that for me. This should have been look for GCF first. And then step 2 is where you look for your perfect squares if there are any. A perfect squares could look like either a difference of squares, or it could look like a perfect square trinomial, 2 terms if it's a difference of squares, 3 terms. And then if we're at a point where it is not a perfect square trinomial and it has 3 terms, then we go on to step 3 where we do that box method from last time. Okay, that was our also called Brownie phase factoring because we had to multiply some factors to set up our diamond. Okay, so we're going to go through that same process here again today, but we're going to see some special cases that allow us to skip some steps. Okay, so here, first one, we're looking for a GCF, and there isn't one. And perfect squares, first term is good, but that 22 is not. So we are back to the box method from last time. So as a reminder, first term and last term go in your box. And then you multiply those together for your diamond, 22x squared, and middle term goes down here. And so we're looking at the factors of 22 that add to be 13. Okay, there are only a couple sets here that could be possible. 1 times 22 doesn't work, and 2 times 11 does work, so that's the pair we're going to use. And those go in your box here. Either way, remember on those, and then we GCF all the way around. So first row, x can come out. Second row, an 11 can come out. And remember, the sign of that goes out front, so that's a plus 11. Going down, x comes out. The second one, 2 comes out. Sign of this is positive, so it looks like a plus 2. So we are left with x plus 2 and x plus 11. You get to group those in whichever order you want. Just a reminder, you want to double check always that your factored form matches this. First term times first term should match that front half. Last times last should match over here. And then your outsides and insides together go to that middle term. So this would be 11x plus 2x gets us 13x. We're golden. Put a box around it. Okay. I want you to take care of the second one. Okay, thinking through these same steps for me. Pause the video to do that. And then we'll chat about the new pattern for today. Okay, this one, a squared here, negative 14 here. We're looking at the factors of negative 14a squared that add to be negative 5. So we've got a 7 and a 2, but we need a negative 7 to make this work. So again, whatever order you want, just make sure you get an A on both those. And GCF all around, A here, 2 here, positive because the first term is. A this direction, negative 7 because we see a negative out front. So this is A minus 7 and A plus 2. Okay, so here's what's different today that is not necessarily the same as last time. It really adds a little diversion here. Okay, if we have a special case where there were 3 terms, but it wasn't a perfect square trinomial, this box method is useful when we've got a other than 1. So if this front term has a number in front of it, then the box method is our route we want to go. But then we also have this option when a is equal to 1. And when that's the case, you can actually skip straight to the diamond here a little bit faster. So here's how it works. When you look at this, I want you to notice something that showed up. This negative 14 ended up being the same number as our C term because there was a 1 in front, so it didn't change that coefficient. And then this bottom term, this is my A, this bottom term here directly matched the one in the middle. And then if you look at our answers, these 2 numbers are the exact same numbers that we ended up having in our diamond. So when A is 1, we can actually save a step here of this box and just fill out the diamond part, because these are what are going to end up here. It looks slightly different. We're still going to multiply these together, but I don't want you to include x if you're using this shortcut. So this is negative 12, and this is positive 4. We're looking at the factors of negative 12 that add to be positive 4. Okay, so we've got 6 and 2. And then we need a negative to show up here, but not here, so minus goes there. And why this works out is because we can think about this as our factored form, just like we check it. We know the first term times the first term has to match this. The only way we can get to x squared is using x and x. And then our last term just cares about getting to negative 12, and that's this one was negative 14. So we just need the two numbers here. We don't need the x's involved, the 6 and the 2. One positive, one negative, just like we had here. Okay, but again, we want to check our middle term. So this says negative 2x, this says positive 6x, and that gives us a positive 4x, so it all checks out. Now, remember, all of these are going to be mixed together. Today we're focusing on when there's nothing in front, so this shortcut applies. But when they're all mixed together, we have to make sure we realize that this method does not work when we're talking about the box method, because x times x is not going to equal 2x squared or 3x squared. So if there's a number in front, this doesn't work. Okay, so looking at the next one, because there's no number in front, okay, this could be a possible method where we get to use the shortcut, but you still want to look for perfect squares. We don't have one here. So in this case, when I multiply these, I just get 10, and I'm looking for 7. So factors of 10 that add to be 7 are 2 and 5. I can multiply to get to t squared using t and t. And then we've got a positive 2 and a positive 5 here. Checking it, t squared works. 2 times 5 is 10, that works. Outside is 5, inside is 2, that gives me 7. It all works out. Okay. We're going to see negatives in different portions, so we'll practice with that. Again, in my box here, negative 24, and then we've got a negative 5. The factors of these ones are going to be 8 and 3. Okay, we want the negative 5, so we got to put a negative with that larger number. And can I set this up? X times x, negative 8, positive 3, whatever order here. If you have these flipped around and use plus first, no big deal. But we're checking it. X times x is x squared. Negative 8 times positive 3 is negative 24. And a positive 3x minus 8x is negative 5. It all works out. Okay. One more here for this practice part. And sorry, b squared minus 4b plus 4, no number in front. This is a perfect square here. This 4 is. All right, we want to check for that. So when it's a perfect square, we're thinking maybe the square roots might work. And then sign, but we have to double check it. Does negative 2b doubled equal that? And in this case it does, which means we get to write it twice. Okay, but I want to show you this works with our same process that we were doing before. This is a positive 4, and I'm trying to get to a negative 4. So the only way that works is with a negative 2 and a negative 2. So it's going to work with this same process, even though this is a perfect square trinomial, that I could also have written as the quantity b minus 2 squared. Okay, I will take either version of these, but I do want you to keep looking out for these, because perfect square trinomials, they don't have to be small numbers. Okay, this could have been a 81, and we don't want to have to take 81 times 4, because then our numbers become so large. So keep looking out for those. All right. On here, okay, I'm going to have you pause the video and try these 3, and then I'll flash up the answers for you. All right, check these out. Okay, 3 and 1, 4 and 8, negative 2 and negative 1 in order to get that negative 3. So now we're going to talk about solving equations using the same process. Okay, what we have to think about is how our solving a equation adds a couple pieces. The first piece is we want equal 0 to happen. Then the second piece, we're right back where we were with the factory. After we look for a GCF, we're going to have to look for perfect squares, but there are two options. You can have a difference of squares, or you can have a perfect square trinomial. Remember, that's 2 terms versus 3 terms. Trinomial means 3. And then if not, then we're on to step 4. Okay, and that's where A is 1. If so, we can factor easily. Plop our numbers, just use the diamond. If A is not equal 1, we're going to use the box method. And last step of all of these is using the zero product property to solve. It's a lot of steps here, but most of them you're not writing anything, you're just thinking through, so we know the best way to factor this thing. Okay, so first one's already equal to 0. We don't have a GCF, and when we have 3 terms, y'all, if this first term doesn't have a number in front, you're not going to have a GCF that you need to worry about factoring out. So that's kind of a red flag that we kind of get to skip all the way to this A equals 1. So I know that x times x is going to happen. And this time I'm tacking on that equals 0. What I need to decide is what are the factors of 3 that give me -4 to plop in next to them. So that's a -1 and a -3. And then we talked about this last time, that all you have to do is switch those signs for your final answer. Okay, remember, for equations, I'm going to have you circle 2 things, the factored form and the answers. I will grade both. Okay, same concept on this one, number 11. We've got equal 0. That's first step. GCF, there is not one. Then we're looking for perfect squares. I have one. But if I think about the square roots here, y and 2, if I multiply those together and double it, I'm not sitting at -5. Okay, so this is not a perfect square trinomial, but it is one of our factoring patterns with our A equals 1. So we're starting with y and y equal to 0. And then we're trying to find the factors of 4 that add to be -5. Okay, so for this one, we've got 4 and 1, and they both need to be negative. 2 answers, +4, +1. I want a box around both of them. Okay, number 12, the same concept, no GCF. Looking like our A equals 1, because again, while this is a perfect square, 3 times m doubled is not equal to that. So we're going back to our m and our n equal to 0. Looking at the factors of 9 that add to be 10. So that's 1 and 9 with both positive. Answers then, of course, flip around, end up both negative. Okay, the only thing different on these next 2 are that we have that first step that's going on. We got to get that thing equal to 0. Now here's the weird part. We've talked about this a little bit, but we only rearrange terms and we only move terms so that we keep this squared term first and that squared term positive. So we are going to subtract both of those pieces over. That becomes -x and -2 equals 0 before starting. From there, we're going through the same process, looking for GCF. There isn't one, nothing in common with all 3. And because we've got just an x squared and no perfect squares, we're starting with x times x equal to 0. And looking for those factors of -2 that add to be -1. Okay, so those for us are a -2 and a +1, whatever order you want. So final answer switches to 2. and -1. Factored form and the solutions for those. I'm going to have you pause the video and try 14 and 15 for me now. Should have been here. -5 equals 0. So we've got x minus 5 and then x plus 1. Make sure you have that equal 0 on your factored form. It's required. And then +5, -1 to finish up. This one was actually a perfect square trinomial. So you could have factored it as that squared, or you can write it out twice. If you missed that on accident, no problem here because these numbers are small. It's okay to find factors of 36 that give us -12, and it works out nicely. The only problem of skipping that is when you have larger numbers. We want to just keep thinking about that as an option. But as a reminder, with perfect square trinomials and equations, there's only one answer, but we call it a double root. Make sure you get that attached. Alright, for these ones, okay, I have them 16 through 18, where we have to pay attention to some order issues as well. Okay, so here, when we move stuff over, we have to be careful. We're so used to just moving one piece and putting it on the end. But watch what happens when I do that. If I put the 7t here, this is an issue. It's really important when we're solving these problems that they have been in standard form. That means squared goes first, then the single letter, ours is t, and then the constant at the end. And from there, it's the same process. Okay, you have to rearrange it first. Okay, so I'm going to go through here and let's talk that through, and then I'll let you go ahead and solve them on your own. So here, this one, we want to keep that p squared positive, so that means subtracting over the other two pieces. And because I'm subtracting both of them, I'm going to go ahead and just put them in order to start with. So p squared minus 9p, and then adding the 14 over equal to 0. Okay, so from there, it becomes like our other process. I'll let you again solve that one. Very last one over here, when we reorder it, we don't have to move the sides of anything, but we do have to rearrange it because it's not in standard form. So I'm starting with my x squared, then I'm going to my single x, so that's the minus 8x, and then I'm writing my constant last. Okay, now that those are all in order, I want you to pause the video and finish those out for me. Factor and solve. All right, check your answers on these ones. Okay, all of them have those a values of 1, so we didn't have to worry about using the box method. Okay, just be sure you get that equal 0 on the equation, and your answers flip signs from that factor form. Okay, the next ones are not, this is going to be how all of the work we do from now on is going to look. Okay, and that's where all of the types that we've talked about get mixed together. Okay, so using that little flow chart that we made is going to help you think through the process. So I am going to let you work through these problems, again, because we've talked about all of them. Okay, this is numbers 19 all the way through 24, okay? And then I'll walk you through all of them with the answers after you're done. But I want you to attempt every single problem. If you get stuck, skip it and come back. Okay, but try every problem and then come back. Okay. This one, the GCF is 3 and x. Remember, when we're talking about two terms, the only options for two terms is difference of squares. This is not a difference of squares, which means you could have solved it with GCF that first step. So 3x times 2x plus 1, and then we've got 3x equals 0, and 2x plus 1 equals 0. So my first one is just regular 0, and these ones will always have 0 being an option. And then -1/2 for the second part, opposite of this, divide by this. Okay? And that may have been the one you found the hardest on this. Okay, the next one, if you take out a GCF, we've got x squared plus 4x plus 3. And this thing inside, because it just says x squared, is actually what we did today. Okay, we can skip to just x times x because there's nothing in front. So I'm looking at the factors of 3 that add to be 4. 3 and 1 are your only options. And so final answer is -3, -1. This one, GCF first, they're both even, so at least a 2 goes in, and this time that was the largest thing that went in, 4x squared minus 9 equals 0. Now what tells us we're not done here is this still says squared. And if this says squared still, we're not ready to set the pieces equal to 0. This thing has 2 terms. And because it has 2 terms, our option for it to keep going is difference of squares. Okay, hopefully you notice that those were both perfect squares. And when they're both perfect squares, I want you to start with these 2 sets of parentheses and just think through square roots. So here we've got square root of 4x squared is 2x, and the square root of 9 is 3. We just have to decide how do you multiply to get to a -9. That means 1 positive, 1 negative. Okay? Because there's no middle term, you have to have opposite signs so that those middle 2 terms cancel out. Right? But there's 3 pieces here, only 2 total answers though, because that first one, 2 can't be equal to 0, that doesn't work. So your 2 answers are a -3 over 2 and a positive 3 over 2, in whatever order you like. Okay, so remember, 2 answers on these, the factored form and the solutions. Okay. This one here, there was also a GCF with 5 can come out. So x squared plus 4x minus 12 equals 0. If you miss a GCF on this and you're trying box method, okay, that's -300, and it's going to take you so long to figure out the factors that give you 20, and your final factored form won't be correct based on you missing the GCF. You'll still get the right answers, but you'll have to reduce. Okay, from here, life is easy because this is an x squared. We can just say x times x. And we're looking at the factors of -12 that add to be 4. So here we want a 6 and a 2, and a negative with that 2. So there's my factored form, including the 5 and the equal 0. And my 2 answers are -6 and positive 2. Last couple problems here. This one, there was not a GCF. These numbers look pretty big though, so it's scary if you try to take 4 times 81. Again, it's too large. This is a perfect square trinomial. Okay, we know this because we're taking the square roots. We're checking it. This is 18. 18 doubled gives me 36, but only if I have a minus sign. So they both have to be that 2x minus 9, which means I have one answer, just the 9/2, but it happens twice, it's a double root. Okay, remember you can, on these ones, if you want, write them as the thing squared, but to keep you really clear on the difference between the difference of squares where they are opposite and the sum, or the perfect square trinomials, just to write it out and think about how to get to that sign. Okay, last one. This is x and x again, and we're trying to get to -90. 9 and 10 works because we have a -1 we're looking at. Okay, so if it's a -1, we need -10 and a +9. 2 answers are 10 and -9. Okay, on your homework, don't forget the box method. And in fact, if you want to, if you're worried that you're going to mess some of these up because some of them will have A values, numbers in front, and some of them won't, you can always go back to what we did on the front side, where you use the box method for these first two, because this method works for everything. It's not always the fastest way to get there, but it is a way that works for everything except for your plain GCF problems. Okay, so you can always default back to it.